So last lesson we're going to look at this week is still 6364, okay, the fourth part, and it's just a little bit more on exponential functions. So most of what's in this lesson we've already talked about, right? But we'll just see if people will kind of remember, what we've done. And if there's some extra time at the end, you'll have time to start the homework. All right, remind me one more time, what's our formula that we always use for the graphs that are exponential?
Y equals A times B to the power of X.
Yep, y equals A times B to the power of X. Yeah. And what happens when the B value, and I think you already have this part written. So in that function, what happens when the B value is between 0 and 1? What do we call that?
Exponential decay.
Perfect. Yep. That's what I underlined. You'll need to fill in. Okay, so in the function y equals ab to the x, if the b value is greater than 0 and less than 1, so like 0.6 or something like that, then that is exponential decay. When you draw something that's exponential decay, how does it look like as you go to the right? Does it curve up, or does it curve like, does it get like flat? How does an
It curves down.
Yeah, it starts to curve down, and then it kind of looks like it flattens out. It never really flattens out, but it gets flatter and flatter. Yep. So that's exponential decay. All right, let's look at this. Let's look at this one. So it says, tell if the graph is exponential growth or decay, and then write a rule for the function. Okay. So you guys already have that drawn on your guided notes. Okay, so first part of the question. Is this exponential growth or decay?
Growth.
Yep, it's definitely growth. How do you know by looking at it that it's growth?
Because it curves upwards.
Yeah, because it curves upwards, okay, as you go to the right. All right, we'll start with that. So exponential growth. And now it says write a rule, okay, or basically write a formula. Okay. I scrolled down too far, sorry. All right, so it's exponential growth. What's the pattern again that we're using? What's the formula?
Y equals A times B to the power of X.
Y equals A times B to the power of X. And what are the two letters that we have to figure out?
A and B.
We have to figure out the A and the B. All right. Steps to. All right. So let me give you the steps, and then we'll try to do it. Okay. So we figured out it was growth. You really don't need any steps to do that because it curves up to the right. Now we got to figure this out. Okay. So here are your steps. Okay. We already did step 1. Determine if it's exponential growth or decay. If it goes up to the right, like that, that is an example of growth. If it goes down as you go to the right, that is decay. So in that step, there's really no math you have to do. There's no calculation. You're really looking at the picture.
Are we just writing that on number 1?
Yeah, that's what you're going to write where it says steps to write an exponential from a graph. Really, I forgot one word there. It should say function. Steps to write an exponential function from a graph. That's okay. All right, so first determine if it's exponential growth or decay. Okay. The next step, step under line 2, you want to write the exponential formula, write the exponential function formula. All right, you guys have already reminded me a couple times what that is. What's the
AB.
Yep.
Of X.
AB to the power of x. Yep. So that's your step 2. And what are your 2 letters we got to solve for?
A and B.
A and B. Yep. Solve for the A and the B. And that's what we're going to do in step 3. So it says plug in the y-intercept. That's your A value. Okay. Let me go back up to the graph for a second. I'll come back down so people can write that. But look back up at the graph. What's the coordinate of the y-intercept in that graph?
0, 10.
0, 10. Yep. And remember what we said about the A value. It's always the number that's with what in the table?
0.
Yeah, it's always the number that's with 0. So you're just not looking at it as a table, you're looking at it as a coordinate. But 10 is the number with 0. So that is your A value right there. It's the number with 0. Right? So that's what the first part says. Look at your y-intercept, and you look at not the 0, but the number that's with it. So in our case, it's the 10. If you look at it as a coordinate, it's what's in that box right there. All right. And now the other thing we need is B. Now when we have a table, usually we can just look at the table and see what we multiply by each time. Well, we don't have a table, so we can't do that. So we got to do something a little different to find B. To find B, what's going to help us do it is the other coordinate. Okay, in our case, the other coordinate is 1, 12. That's the other coordinate. We're going to use those 2 numbers, the 1 and the 12. That's going to be the x and the y. And the 1 and the 12 are going to help us to figure out B. All right, so let's try to do what it says. Y equals AB to the x. What letter do we already know in that formula?
A.
Yeah, we already know A. It's the number in the coordinate that's not the 0. Okay, so let's look at the y-intercept. What's the number in that coordinate that's not the 0?
10.
10. That's how you plug in, that's how you find your A. Okay, so A is 10. Now B, we don't know. So we're just going to leave the B for now. But the y and the x, we do know. The y and the x come from the other coordinate. So let's go back up and look at the other coordinate. What's the other coordinate they gave me in that picture?
1, 12.
1, 12. Which number there is the x? First one. Which number is the second one? I mean, which letter is the second one?
Y.
So in this case, x is going to be 1, y is going to be 12. We're going to fill in those 2 numbers to find B. So x is going to be 1, y is going to be 12. Right. And now, solve that for B. Okay, so when we're done, off to the side, we're going to know these 2 things. We already know the first one. All right. Okay, so when you solve it, let's start on the right-hand side. Think about PEMDAS. It's raised to an exponent. That's the first thing we need to do, exponent. What's b to the first power? What is it? It's just b, right? When you raise something to the first power, that doesn't change it at all. So b to the first power is really just b. Now, we have 10 times b on the right side. We don't want that 10 there. We want to put the 10 on the other side so we can get b by itself. How would we put the 10 on the left side?
Divide.
Yep, and what would you divide each side by?
10.
10. What's 10 divided by 10?
1.
1, that cancels out. So what's on the right-hand side now? Just b, that's all we've had there. And what's on the left side right now?
12 divided by 10.
12 divided by 10. So let's just use the calculator. 12 divided by 10. That's your b, 1.2. Right, so now we know b. All right, so we've got the a, we've got the b. Can somebody tell me the final answer? Plugging those two things in and leaving it just like that. Yeah.
12 equals 10.
Well, remember, when you write your final answer, we're just going to fill back in for the a and the b.
Okay.
So we're going to leave the x and the y. We only had to fill in for the x and the y temporarily to figure out b. But now we have b.
Okay, so it's y equals 10 times 1.2 x.
Yep, to the x. Perfect. That's the final answer. 10 times 1.2 to the x. So just to be clear, we only filled in for the x and y temporarily because we didn't know b. Once we get b, we don't fill in for them again. We just leave our answer the way we're always used to seeing it. Put the a, put the b, and you're done. All right. Oh, so there was a step 4, which we already did. Write your answer in y equals ab to the x. And it says just filling in for the a and the b. That's what we just put a box around right here. All right, so you can write down step 4, but we already did it. I'll just copy it down. So the a, you're never going to have to solve for that. That's always going to be something you can get by looking at the graph. The b, you're going to have to solve for that. Okay. All right, now let's look at a picture of what we just did. Is this going to be growth or decay? Yeah, this is going to be growth. How come? Yeah, because it's above 1. So that means it should curve up as we go to the right. And it is curving up. I just didn't zoom out enough to see it. Okay. And if I look at my table on the calculator, I don't want to look at the whole table, but just look at the first 2. What do you notice about those 2 things I circled and what they gave you right here?
They're the same.
Yeah, they're the same. When x is 0, y is 10. When x is 1, y is 12. Yep. So because they came out exactly the same on here from what they gave me, I know we did it correctly. All right. Any question on that? Alright, so I think there's one more like that. Okay, I'm gonna let you guys try it. Okay, so on the back. So example 2 is the same directions as example 1. First, tell me if this is exponential growth or decay. And then I want you to find a formula. Okay, find a formula for that equation. So remember, to find the formula, off to the side, you need to figure out those two things first. Then you can fill them into your formula. Yeah, question? Yeah, just saying. All right. So what's the equation that we're using? Let's start with that. It's the equation for all exponential functions.
Y equals A times B to the power of X.
Yep, y equals a times b to the power of x. In order to write something in that format, your final answer has to have a number there and a number there. Okay. Those are the only two spots you need to fill in numbers for. So off to the side, I put a little box to find those numbers. Let's start with A. Anyone think they know what A is in this case? Yeah?
8,
8. How do you know it's 8?
because on the graph it's 0 and 8.
It's the number that's with 0. It's the same rule we've been using all week, except I don't have a table here.
The y-intercept?
Yeah, it's the y-intercept, exactly. So the number with 0, which is the y-intercept, is 8. Okay, is that enough information to write my final answer? What do I still need that I don't know yet?
B.
I still need b. So to find b, it says plug in the y-intercept, which we just found, and use the other coordinate to solve for b. What's the other coordinate in this problem that we didn't use?
1, 4.
The 1 and the 4. The 1 is going to be which letter in this formula? The 1 is going to be the x, and the 4 is going to be
The Y.
the y, and the 8 is going to be the
A.
a. So we have everything that we need, and we're going to find the b. Remember, when we fill in for x and y, this is just a temporary thing. We're not going to leave the x and the y in the final answer. It's just so we can figure out b. So let's go through it. Start with y. Eli, what am I going to plug in for y?
8. Or no, Y?
Y. Someone help them out. What did we just say y is going to be? 4. Okay, y is 4. What are we going to plug in for a?
8.
8. What are we going to plug in for b?
Nothing.
Nothing. We don't
We
know.
don't know that yet.
That's the whole point. And what are we going to plug in for x?
1.
1. All right. So now, do your exponent first. What's b to the first power?
B.
Just b. But now we got to get b by itself. So what's next to b that we don't want next to it?
8.
8. How do you move the 8 to the other side?
Divide.
And what do we divide each side by?
8.
8. 8 divided by 8 is gone. And there's your answer for b, but we can reduce that. What's 4 divided by 8?
1 over 2.
1 over 2. Yep. Okay, so that's the hard part. Now we know the a and the b. So now write your final answer, filling in just for the a and the b. Leave the x and the y in the final answer as letters. So, anyone think they can tell me the final answer?
y equals 8 times 0.5 to the power of x.
Yep, you could do 0.5 or you could do 1/2. Same thing. But that's how your final answer should look. Yes. Yep, just sign up. Any question on that one? So we did finding an equation for a decay graph, and then the first one we did was finding an equation for a growth graph. So we covered both types. All right, so just like we did with exponential growth, I'm going to give you a formula for exponential decay. And it's going to be extremely similar to the one for growth. There's only going to be one thing in the whole formula that's different. And I want to see if you can tell me what is different. So that's the formula you want to write down. What's different?
Symbol,
What's simple?
the plus sign,
Yeah, what did the plus sign turn into?
turn into a subtraction sign.
It turned into a subtraction sign. This is the only thing that changed in the formula. The one I gave you guys before was a times 1 plus r to the t. This is a times 1 minus r to the t. Every letter still stands for exactly the same thing it did before. A is the initial amount. That could be an initial amount of money, could be an initial amount of people, butterflies, it could be anything, but it's the amount you start with. R is not the growth rate, R is the decay rate. So that would be like if I said the population of a city is decreasing at 5% each year. Because I use the word decreasing, that's decay, it's going down. If I said the population is increasing at 5%, that's going up. And T is the time period. Sure, I put to find there. Just the time period. Does everybody have the formula for exponential decay? All right, so let's look at example 3, and then there's a few other practice examples. I don't think we're going to do all 6 of them, but we'll do a couple. Okay, so this is example 3. It says the number of acres of pine forest decreased in the western U.S. by 0.5% annually, 0.5% every year. What word here tells you that this is going to be decay and not growth?
Decreased.
Right. When you see a problem that has the word decreased in it, that means it's going to be a decay problem. That means you need to use this formula. What word would you see here if it was about growth?
Increased.
Increased. Yep. So it says in 1963, there were 41 million acres of pine forests. You have all that written down. Find the number of millions of acres of pine forest in 2002. Okay. So let's write down our formula, and then let's figure out everything we have to plug in. Okay, so let's start with A. A is the initial amount.
41 million.
Yeah, the initial amount of acres we started with that we're measuring, we're measuring from 1963. Okay, so that's 41 million. We're just going to use the number 41. But we got to remember, when you get an answer from this, it's in millions. Okay, so that's really 41 million. So let's say we plug a number in and the answer comes out to 22. It's not 22 acres, it's 22 million acres. Okay, my decay rate. The decay rate is 0.5%. It's pretty small, okay? Still adds up over time. But what do you do with your decimal to change the percent to something that we can plug in?
Move it to the left twice.
Move it to the left twice. 1, 2. So now your decimal is right here. So what's the value that we're going to plug in for R?
0.005.
Yep, perfect. 0.005. In T, this is years since the beginning. And when was the beginning? Well, for our problem, it was 1963. That's the beginning. What year do they want us to predict the amount of forest that'll be left?
2002.
2002. Okay, so we're just checking to see if this model was accurate in the past. So we have to figure out how many years since 1963 is 2002. How could I use my calculator to do that?
You would do
27?
2002 minus 1963.
Yeah.
27 years?
So 2002 minus 1963 gives us 39 years. Throwing. All right, so this is years since 1963, 39 years. Did anyone have a question why we did 39?
I mean, it's still dated. Can't change that really.
Yeah, we can't. It's just that's what they want us to do. They want us to predict for 2002. All right, so let's plug in everything, and we need to do it out and see what we get. Okay, so we have y equals. Okay, what are we filling in for A?
41.
Okay, so 41. 1 minus, what is my decay rate?
0.5.
0.005. And what's the value for t? T is the number of years that have gone by.
39.
39. Yep. All right, so let's, what I would do is simplify what's inside the parentheses first. 1 minus 0.005. So that's 0.995. Now you can type that all in on the calculator exactly the way you see it. 41, parenthesis, 0.995, exponent, 39. So should this be more acres of forest or should it be less?
Less.
It should be less because it's decaying. So we started with 41 million acres, and by year 2002, it should be down to 33.7. Is that 33.7 acres?
No.
33.7 million acres. Yeah. I think it was it acres? I think it was measured in acres. Yeah, acres. Any question on that one? So there probably will be some kind of word problem on the test. But as long as you write down, I think we did 3 formulas this week. We did the exponential decay, we did the exponential growth, and then I gave you one for interest rates, which was really exponential growth, but just specific to banking. So let's see. All right, let's try one more of those, because I think some people had trouble doing that. So this is what we did right at the beginning. I've given you a graph. I want you to write if it's growth or decay, and then if whichever one it is, give me a formula. Okay? Like the y equals ab to the x. Put that one up.
That practice has
That's practice A. And this one is practice B. You don't have to copy down the whole problem. Okay, practice B says write an exponential function to model the situation. A population of 410 animals decreases at a rate of 14%. They're not asking you, like in the last problem, to figure out how many animals will be left in 2002 or something. You're just writing a formula. You don't have to plug anything in and use the calculator. Just write the formula and you're done. Let's try those two, and then when you get those, just call one of us over and we'll take a look. All right, so let's take a look at practice A. Okay, what are the two letters that we need to identify? Because we're going to need these for our final answer.
A and B.
Yep, we need the A and the B. Is there one of those that we can see just by looking at the graph?
Yes.
Yep, which one?
A equals 4.
Yes, A is always the number with 0. So we know A is 4. How am I going to get B?
You have to fill in the other coordinates.
Yep, we're going to take the other coordinate. We're going to fill it in. So y in this case is 2. A is 4. B, we don't know. That's what we're trying to find. And what's x? X is 1. And now we're going to solve that for b. What's b to the first power? B. So that's 2 equals 4 times b. And what number do we have to get rid of so b is alone?
4.
And how do we get rid of that 4?
Divide.
Yep. Divide by 4. So when you divide the left side by 4, you get 2/4. And when you divide the right side by 4, you get b. So what does 2/4 reduce to? What is it? Yep, 25 or 1/2. Yep. Okay. So what is the final answer?
Y equals 4, and then parentheses 0.5, and then x.
And then x. Again, if you put a 0.5 here or you put a 1/2, they're both correct. That's the same number. All right. And how about practice B? Okay, so let me pull up that formula. A times 1 minus r to the t. Okay. A times 1 minus r to the t. Anyone think they got the final answer for that one?
Yes. For B?
For B, yep.
Yeah,
we're not doing C or D.
Y equals 410, parentheses 0.86, okay, to the power T.
Yep, y equals 410. I just didn't do the last step. 0.86 to the power of t. Perfect. Okay, so just a reminder, okay, homework tonight, 6364. I think it says part 4. Let me double check that. Yep, it says 6364 part 4. Oh, yes, it does say test review when you get in the folder. So click on that. And that is your homework for tonight. I think it's 12 questions? No, 13. 13 questions. Okay, so we'll go over that first thing tomorrow. Reminder, I have my extra help after school if anybody needs to stop by. test on Friday. And that's it.